All right, sequences in explicit form. So a sequence is simply a list of numbers that has some kind of a pattern to them. Some people can look at the sequence of numbers and they can instantly figure out what the pattern is. Some people, it takes a little bit more work for them to figure out the pattern. It doesn't matter. It's not going to change anything if you need to take a little bit longer to figure it out. But with our sequences, each number is what we refer to as a term. So the number 1 up here is what we call our first term. That is our first term in our sequence. Couple of ways we can write it. We have 2 different kinds of notations. So we can either write as a sub 1, and that 1 is a little 1, just kind of like back when we had our logs, our bases were those little numbers. So that's a sub 1, that's how we can represent our first term, or they can write it kind of like a function notation style, which would be your a of 1. They use both of those interchangeably. There's really no rhyme or reason as to why they use those 2 terms there. So then number 10 here, that just simply represents our 4th term in our sequence because it's in the 4th position there. So that would be a sub 4. Or again, if we were going with our function notation, that would be represented by a of 4. And then all of our dots at the end there, that tells us that this is an infinite sequence. So what does it mean to be an infinite sequence? Never ends. So this pattern just continues on forever and ever and ever and ever. So when we're dealing with infinite sequences, we have what we refer to as the nth term. So the nth term is just referring to some term in the future. We don't know which one we're looking at, but we're looking at a term way beyond in the future. So again, using our 2 notation styles, they would write it as a sub n or a of n. So that just means, again, some term in the future. So as we have written down here, n just represents what position in the sequence are you in. So if I have an n of 7, that means I'm looking at my 7th position of the sequence or my 7th term. So then down here we also have 3 other very common ones that we see. A sub n is the number in position n. A lot of times that is also referring to what we call our current term, the term that we're actually dealing with at that point in time. A sub n minus 1. That one refers to our previous term. So if a sub n is our current term, n minus 1 means we go back to the term before it. And then our last one over here, n plus 1, that would be our next term. Because again, if we're at our current term of n, adding 1 to it means we're going to go to our term just after it. So that's going to be our next term. We'll deal with those a little bit more when we get to our recursive. So what is a sub 4? Looking at our first question here, what is a sub 4? So a sub 4 just means you're looking for the 4th number in the sequence. So if I look at my sequence up at top, what's our 4th number? So a sub 4 equals a 10, because 10 is the number that is in the 4th spot. So this means 10 is the 4th number in the sequence. Or 10 is in the 4th spot. Whatever way you want to refer to it, it means the same thing. 10 is that 4th number, 4th term in our sequence. So looking at our sequence, 15 is in what position? 15 is in the 5th position, so that means our n would be a 5. So we could write that as a sub 5 or a of 5. It's just in that 5th position there. And then they said if a sub n equals 21, what is n? But is there a 21 in our pattern yet? No. Has anybody figured out the pattern? Add 2, and then you're adding 3, and then you're adding 4, plus 5, so then plus 6. There's our 21. So yeah, 21 is in the 6th position. Good job. So n is a 6. So the rule for this pattern is right here. Rule is just another word for our equation. So find a sub 7 using this rule. It's just like our function notation. So a sub 7 just simply means we are plugging a 7 in for all of our n's. So a sub 7 would be 1/2 times 7 squared plus 7. So 7 squared plus 7, what does that give us? 56. And then times 1/2. Give us 28. So our 7th term in that sequence is going to be a 28. So this rule here that we had there, our 1/2 times n squared plus n, that is what we call an explicit formula. That one is called an explicit formula because you can figure out any term that you want at any given point in time. So I could sit here and ask you to find me the 100th term. All you'd have to do is plug in your 100 for your n. You can figure out that term. So our explicit formula is based on position. You can figure out any position in the sequence that you want using your explicit formula. So down here we have a different explicit formula. We have a sub n equals n minus 1 over n. They want us to write out the first 4 terms of the sequence. So to write out the first 4 terms, you start with number 1, and you're going to plug in 1 for all of your n's. So that would give me 1 minus 1 all over 1. And then what does that simplify down to? 0. So then figuring out our second term, we're now just going to plug in a 2 for all of our n's. So what do we get for our second term? 1/2. Third term, we're going to plug in a 3. So we get a 2/3. And then fourth term, we get 3/4. So our first 4 terms end up being 0, 1/2, 2/3, and 3/4. So with your sequence, you can take those numbers and you can put them into a table. If you prefer to use tables to help you figure out your answers or to figure out through the patterns, you can do that as well. So again, your n here, that's still representing your position. So we got our first position, our second position, third position, fourth, and fifth. And then our a sub n, that just is your number. So 1, 3, 6, 10, 15. So this is still the same pattern that we had on the front that we were working with. So again, you can use a table. So what is a sub 5? So if we got our table, a sub 5 just means we're going to go to our 5th position, and then that gives us 15. A sub 5 would be 15. So the number in the 5th position is 15, is the way we can read that. So then what position is the number 6 in? 3rd. because you go to the 6, and again, that X portion of that table, that represents your position, so 6 is in the 3rd position. Again, what is the n for term 21? Yeah, we had figured that one out on the front. So then D, given the rule, and it's still the same rule, 1/2 times n squared plus n, figure out a sub 8. What do we get? What's a sub 8? 36. So again, explicit formula, you can figure out any position, any given point in time. So down here, we have given each of the following sequences defined by formulas, determine and label the first 4 terms. A variety of different notations is used for practice purposes. So as I was saying, you can use function notation, like what we have in example C and example A there, or the other notation, the a sub n notation, which we have in B and D. So all we have to do is figure out and practice finding the first 4 terms of these sequences. So for letter A, we want the first term, bless you, so f of 1. So we're going to head plug in a 1 for our n. So 7 times 1 plus 2 gives us 9. So our first term is a 9. Second term, plug in a 2. What do we get for our second term? 16. Third term, we're going to plug in a 3, so 7 times 3 plus 2, 23. And then our fourth term would be 30. Now, it said to determine and label the first 4 terms. So since I have this f of 1, and then this f of 2, f of 3, f of 4, that's me labeling my first 4 terms. So that fulfills that part of the problem. So I want you to take a few minutes, figure out the first 4 terms for B, C, and then D. So now picking back up, we're going to talk about recursive formulas. So recursive formula is another way to be able to write the equation for a sequence, only gets a little bit more complicated. So here is an example of a recursive formula. We have a sub n equals a sub n minus 1 plus 2. So if we think back to what I was saying on the other side of the page, what does a sub n minus 1 mean? Previous term. This is our previous term. So what's actually happening here is they're telling us to take the previous term and add 2 to it. So that's what our recursive rule is you're taking the previous term and you're adding a 2 to it. So what ends up happening with the recursive formula is the fact that you need to know the previous term. So if you don't know that previous term, you can't figure out whatever current term it is that you are working on. So given this recursive formula, they want us to figure out a sub 7. So if we go through the same steps we were doing with our explicit, and I go down here and I plug 7 in for my n's, on this one right here, when I do this notation and I subtract it, that ends up giving me a 6. That's why it ends up turning into the previous term. So that ends up becoming a sub 6. And again, a sub 6 means the 6th term. So in order to figure out the 7th term, you got to know what that 6th term is, and then you can add 2 to it. So sixth term was 11, and then 11 plus 2 gives us 13. So again, main things we have to remember with our recursive, a sub n minus 1 is our notation that means previous term. Now, if they are writing it in function notation, it would be f of n minus 1. That's how we know they're referring to the previous notation in our function notation. And then as we said on the front, if for some reason you see n plus 1, that means they're referring to the next term. And again, function notation would be f of n plus 1 for that. So a rule that gives you any number in the pattern based on its previous number is called recursive. So recursive is always based upon what the previous number was. So that's the main difference there. Your explicit formula, you can figure out any position at any point in time. Recursive, you got to know the ones leading up to it to get to the one that you want. So let's take a look at our differences here. So I've split it up. We've got explicit formula over on the left side. We've got our recursive formula over on the right side. So let's go through with that explicit. Again, explicit defines the sequence based on the position. What position are you looking for? So write the first three terms of this sequence. So term 1, because it's explicit, means I would be plugging in a 1. So 1 squared plus 1 gives us a 2. Our second term means you're going to plug in a 2, so 2 squared plus 1, 5. And so then our third term, you plug in a 3, so we get 10. So 2, 5, and 10, those are our first three terms of that sequence there. Explain how to find the 10th term of the sequence. What would we have to do to figure out the 10th term? Plug in 10 for n, and then simplify. That's why explicits are so nice. You can easily find any position. So then example 2 there, we have a new formula, a sub n equals n times n plus 2. They want us to figure out a sub 5. So all we have to do is plug in 5 for each of our n's. And what do we end up getting there? 35. So a sub 5 is 35. And then our last one there, they want us to write an explicit rule for the following sequence. So since it's a sequence, you have to keep in mind which term it is that we're dealing with. 3 is the first term, 6 is the second term, 9 is the third term. So with the explicit, I should be able to plug in this 1, and it'll give me a 3. I should be able to plug in 2, and it gives me a 6, and then I can plug in 3, and it gives me a 9. So what's happening to those to give me those numbers? Multiplying them by 3. So if I plug in my 1 for my first term, 1 times 3 is 3. If I plug in 2 for my second term, 2 times 3 is 6. Plug in 3 for my third term, 3 times 3 is 9. So when you're writing those explicit rules, you kind of have to think about, okay, if I plug in my first number to get my first term, how is that going to happen? All right, let's go over to recursive now. Again, recursive defines it based upon the previous term. So write the first three terms of the sequence. So here's our recursive rule. A sub n equals a sub n minus 1 plus 2. So again, this a sub n minus 1, what does that mean? Previous. So this just means we're taking the previous plus 2. Now, the other part of the recursive rule that we hadn't seen just yet is they have to give you a starting point because everything's referring to that previous term. You can't figure out the first term without knowing something. So they have to give you something to start off with. So they give us our first term already. So we have to find the first three terms. They've already given us the first term. So my second term, as we just said, is the previous plus 2. So my previous was a 3. So 3 plus 2 means our second term is 5. So then my third term is the previous plus 2. So my third term is a 7. So 3, 5, 7. Those are our first three terms there. So the next part, explain how you would find the 10th term of this sequence. How could we find the 10th term of this recursive? Yep. Find the first 9. Then you can add 2 to the 9th term. That's how we would get the 10th. Gotta know the ones that come before it. Okay, so example 2, we have a new formula now. So let's take a look at this formula, see what's happening here. So a sub n equals 3 times a sub n minus 1 plus 2. So again, that a sub n minus 1, that means what? Previous. So it's 3 times the previous plus 2. They tell us our first term, because again, they have to. You got to get a starting point. They want us to find the third term. But before I can get to the third term, we got to figure out the second term. So again, we said the formula was 3 times the previous plus 2. So if I'm finding my second term, what was my previous term? Negative 5. The previous term for term 2 would be term 1. So that gives us negative 13. So our second term is a negative 13. Now we can find our third term. 3 times the previous plus 2. So 3 times negative 13 plus 2 will give us negative 37. So our third term there is negative 37. So in the last part, write the recursive rule for the following sequence. Again, when I see that I'm supposed to write a recursive rule, I always automatically write my first term down because, again, that is a very necessary part of your recursive rule. So a sub 1 here is a 27. To write the rest of it, we got to figure out what's happening. 27 to 24 to 21. Minus 3. So my previous term, so a sub n minus 1. And then I'm subtracting a 3 from it. So that recursive always has those two parts. So again, sequences can be written in function notation. It doesn't always have to be the a sub n stuff. So example 1, an explicit sequence in function notation can be written like this. F of n equals n squared plus 1. So using a table, write out the first 4 terms. So go ahead, figure out the first 4 terms of that sequence. All right, 2, 5, 10, 17. That's what we should get. So then example 2, a recursive sequence in function notation looks like this. Again, this is your previous term. That's how we would write it in our function notation. So what's happening to our previous terms? We're just adding 6. So our first term's negative 5, so that's already in our table for us. So all we have to do is add 6, so it's negative 5 plus 6, plus 6, plus 6. There you go. 1, 7, 13. So you need to be able to write sequences in the 4 styles that we have gone over. So first one is a sub n explicitly. Second was a sub n, but writing it recursively. And then function notation explicitly and function notation recursively. Those are the 4 kinds that we've gone over. So let's take a look at our example we have down here. We have 7, 4, 1, and -2. If you want, again, you can write it in a table if that helps you organize it a little bit better. Some people prefer that way, so you can do that as well. So we're going to write it in the 4 styles. A sub n explicitly. That was our first one. So we got to figure out what's the pattern here. What is happening to turn the 1 into a 7, the 2 into a 4, the 3 into a 1. We're subtracting 3, yeah. Does this look like any kind of a function to anybody? What kind of function is constantly increasing or decreasing by the same amount? Linear. So this is going to kind of follow mx plus b. -3 is our what? Our slope. So that would be a -3n. We got to figure out our b. It's not 7 because the b value is always when x is a what? So what would be the other number if I went backwards? 10. So -3n plus 10. We're going to talk about that one more next time also. All right, second one was a sub n recursively. So again, recursive definition always has 2 parts to it. You have to state the first term. So a sub 1 is a 7. And as we already said, it's going down by -3. So we take our previous term and subtract 3. So a sub n minus 1 minus 3. Now for the other 2 styles, our function notation explicitly, is it really going to be any different than this explicit? No, the only thing that's going to change is your notation at the beginning. It's still going to be the same explicit definition of -3n plus 10. How about for our recursive? No, again, it's just going to be that notation that changes. So f of 1 is 7. I still have to state what my first term is. F of n is my previous minus 3. All right. Last thing in our notes for today. Fibonacci sequence. Have you guys ever heard of Fibonacci sequence? Yes. A little bit. Fibonacci sequence is really cool because it just exists naturally in the world. If you care to look for it, it's actually there all the time. Let's see here, it's in math, it's in nature, it's in music, it's in art, science, it's all over the place. So this is the way that we actually write our definition for the Fibonacci sequence, which can be kind of confusing. There's a lot of parentheses and F's and all that good stuff. So let's take a look at each part of it. At the end, they actually tell us what? They tell us that our first term is a 1, and they tell us that our second term is a 1. So they give us the first 2 terms there. So then let's take a look at the rest of it. Hopefully, you are remembering what that notation means. F of n minus 1, that means what? Previous. So then f of n minus 2, what do you think that means? Yeah, I like to call it the previous. So you go back 1 and then you go back 1 more. So that's why they have to give us the first 2, because when I'm trying to figure out the third term, I need to know the one before it, which is the second, and then the one before that, which is my first term. So they have to give us the first two. So to figure out our third term, again, following our rule here, it's the previous term, which would be the second, which was a 1, plus the one before that, which was also a 1. So our third term is a 2. So our fourth term is going to be the one before it, which is the third, which was a 2, plus the one before that, which was a 1. So our fourth term is 3. So our fifth term is the one before it, plus the one before that. So 3 plus 2 gives us 5. And so then our sixth term is the one before it, plus the one before that. So we get an 8.